exercises is to prove that the inverse of a function is a bijection. Okay, so it's all in there somewhere. But yes, then f inverse from B to A is a bijection. This is an exercise. And I promise you, I know you were waiting, hoping that I would give you an assignment earlier. I promise I will give you one today. Okay? Okay? Now, the last thing is transitive. What's my opening line going to be here? So remember, transitive starts with if A, in this case, if big A is equivalent to big B, and big B is equivalent to big C, then big A is equivalent to big C, right? That's a transitive. So what are my actual assumptions now that I'm going to be assuming about the sets A, B, and C? There's what? Or I should say are bijections, okay? F A to B, and what now? Sorry?
G. F, B to C. G from B.
G. I like G a lot better. Okay. Okay. G, right? Because we don't want to use the same letter. It's going completely different sets in general. Be bijections. What I want is a bijection H from where to where?
A to C.
A to C. Okay? Whoever can tell me what that is releases the entire class to go away.
We want G composed with F.
Yes. H we define to be G composed with F. Okay, you now know that it definitely goes from A to C, right? And then it's a homework, so it's an exercise, that H is a bijection. So you remember last time that I did that funny exercise, right, where we knew, one-to-one here, and we knew onto there, and we showed something else is onto. This is actually a more straightforward exercise, but you do have to prove it in your homework that if you have two bijections, then their composition is bijection. This is all extremely important, especially to finite math, so you computer science people think about it, okay? Because, for example, it's how you actually say the size of a set. So how do you say that a set has 5 elements? What do? You say, you count them. 1, 2, 3, 4, 5. So what are you doing? You're making a bijection between your fingers and the elements of that set. And as long as there's such a bijection, then that set has 5 elements. Okay? So this is the basis for how you count finite sets.